In this video, we're going to look at the formal proof that we developed scratch work for in the previous video. The theorem in question is sitting in front of you, and it says that if we have a convergent sequence and we look at any subsequence of that convergent sequence, the subsequence also converges, and it converges to the same point that the convergent sequence converges to. Here is how the formal proof based on our scratch work in the previous video will look. We're going to let the pKs be a sequence that we know converges to X, and we're going to let the pNks be a subsequence of that convergent sequence. So this is a subsequence of my convergent sequence. Now, I want to make a note that the whole purpose of this proof is that I want to show that this particular subsequence also converges to X. And so I need to be able to trap a capital N tail of this subsequence inside any arbitrary open interval containing the real number X. So the next thing that I'm going to do is I'm going to say that we're going to let S be an arbitrary open interval that contains X. Now, the next thing that I want to notice is this. Since the pKs are known to converge to X, there does exist a capital N1 inside the set of integers such that if K is bigger than or equal to capital N1, then I know that pK belongs to the open interval S. Now, I also want to notice something else. Since the pNks are a subsequence of the pKs, I know this as well. We know that the sequence of NKs is an increasing sequence of integers. So N1 is less than or equal to N1 is less than N2, which is less than N3, which is less than N4, and so on. And I also know that those NKs go marching off to positive infinity as K marches off to positive infinity. And because of this fact, I know that there exists a capital N inside the set of integers such that little n sub capital N is bigger than or equal to capital N sub 1. And now look at this. If I pick any K that is bigger than or equal to capital N, then I know that N sub K is bigger than N sub capital N, or equal to it, because K might be equal to capital N. But N sub capital N is known to be bigger than or equal to N sub 1. So that means P sub NK has to belong to S whenever, and let me write that just a little bit more clearly, whenever K is bigger than or equal to capital N. And that's enough to say that the subsequence does converge to X by the definition of convergent sequence. And that completes the proof.